when Australia announced it would wipe out every rat and rabbit on a remote island in the Southern Ocean.
The $24 million pest eradication project on Macquarie Island has had some unintended victims. About 300 birds were killed after eating poison pellets.
The world called it reckless and cruel. Critics said the plan would destroy nature instead of saving it. Animal rights groups labeled it mass extermination. And headlines mocked it as the bait drop of doom. But when the helicopters finally left and the island fell silent, what happened next shocked even the scientists who had risked everything to make it happen. The island that nature gave up on. Few people had ever heard of Macquarie Island before it became the center of one of the most dramatic ecological disasters in Australian history. Lying alone in the freezing waters between Tasmania and Antarctica, the island looks peaceful from above. Green cliffs, scattered lakes, and seabirds gliding over the waves. But beneath that calm surface was a story of slow destruction that scientists would later call one of the worst examples of human-caused collapse on Earth. The island was discovered in 1810 and quickly became a rest stop for sealing and whaling ships traveling through the Southern Ocean. Sailors came ashore to collect fresh water and firewood, often leaving behind supplies and livestock. Without realizing it, they also brought something far more dangerous. Stowaway rats escaped from the ships and quickly began to multiply in an environment that had no natural predators. Years later, other crews deliberately released rabbits so that future sailors could hunt them for food. That single decision, meant as a convenience, changed the island forever. Before humans arrived, Macquarie was a paradise for wildlife. More than 3 million seabirds bred there each year. Giant petrels, prions, and shearwaters filled the skies. The slopes were covered in tall tussock grass, mosses, and megaherbs with massive leaves that trapped moisture and anchored the island's deep peat soils. Those plants were the foundation of the island's stability. Their roots held the soil together and absorbed the constant wind and rain. Once rats and rabbits took hold, the balance fell apart. Rats hunted at night, raiding nests and burrows for eggs and chicks. Entire colonies of seabirds vanished in a few years. Rabbits began eating through every layer of vegetation down to the roots. They stripped hillsides bare and dug deep warrens that weakened the ground. When heavy rains came, the unprotected soil turned into black mud and flowed into the sea. By the 1980s, nearly 80% of the island's slopes were barren. Rangers described them as ghost zones, with no plants, no birds, and no life. The damage went far beyond the loss of scenery. Without plants, the soil could not filter water, and streams became filled with silt. The nutrients that once cycled naturally between plants, birds, and soil disappeared. Nitrogen and phosphorus levels dropped sharply. As layers of peat washed into the ocean and decomposed, they released methane, which contributed to greenhouse gas emissions. Scientists watched in disbelief as each season made things worse. Surveys showed seabird populations collapsing by 90%. Some species that had lived there for thousands of years vanished completely. Botanists returning to long-term research sites found cushion plants reduced from full coverage to less than 5%. Photographs taken decades apart showed entire hillsides that had turned from green to brown. By the early 2000s, Macquarie Island was a landscape of erosion, silence, and death. Experts warned that without drastic action, the entire ecosystem would collapse beyond recovery. In the face of this devastation, scientists began small experiments to contain the damage. The experiments that failed. At first, teams tried to contain the problem using traps, fences, and small-scale poisoning campaigns. The goal was to control the pests without completely wiping them out. Workers set up hundreds of metal traps near nesting sites, but the terrain made progress slow. The island's cliffs were too steep, and many burrows were unreachable. Fences were built to isolate small areas of vegetation, but the constant wind and rain destroyed them within months. Poison baits were laid in sections of the island, and for a short time the rabbit numbers seemed to drop. Yet within a year they were back. Rats simply moved to untouched areas and multiplied again. Every victory disappeared before it could even be measured. Technology at the time made things worse. Helicopters were meant to spread bait evenly across the island, but the conditions made that nearly impossible. The wind often reached speeds of over 100 kilometers per hour, which made flying extremely dangerous. Even when pilots managed to take off, strong gusts blew the bait off course. Instead of covering the ground evenly, the pellets fell in random clusters, leaving large areas untouched. Those gaps became safe zones where rats and rabbits quickly returned and multiplied. Monitoring also depended on basic motion cameras that often malfunctioned in freezing rain. Field teams walked for days to check traps or collect samples. But many burrows remained hidden deep in the rocky soil. The island's unpredictable weather and wet landscape made it almost impossible to cover every corner. In the 1980s and 1990s, scientists turned to biological methods. They released two diseases that had worked on the mainland: rabbit calicivirus and myxomatosis. The two diseases were chosen because they had been effective against rabbit infestations on the Australian mainland. Rabbit calicivirus causes internal bleeding and liver failure. Infected rabbits usually die within a few days, often showing no clear symptoms until the final stages. Myxomatosis is spread by biting insects such as fleas and mosquitoes. It causes swelling around the eyes and genitals, severe fever and blindness, leading to death within about 2 weeks. Both viruses were expected to spread rapidly through the rabbit population and collapse their numbers. The first outbreaks were promising, and thousands of rabbits died. But the relief was short-lived. The survivors developed immunity within a few seasons, and populations surged again. Other attempts created even more problems. Years earlier, feral cats had been introduced to hunt rats and rabbits, but they turned on seabirds instead. Colonies that had survived the first invasion were now being wiped out by predators meant to protect them. These repeated failures took a heavy toll on morale. Scientists describe the feeling as watching a slow-motion disaster. Each partial success came with new consequences. When rabbit numbers briefly dropped, vegetation returned and rats multiplied because of the new food source. When poisons worked, scavenger birds fed on the carcasses and died. Rangers returning each season found the island in worse shape than before. It became clear that every small action triggered another collapse somewhere else. Health and safety risks grew with each campaign. Handling poisons in freezing conditions caused injuries and sickness among field workers. Supply deliveries were delayed by storms, and rescue flights were often impossible. During one campaign, a field technician who had recently become a father after years of waiting fell ill after prolonged exposure to bait dust in the cold. With weather too severe for evacuation, he was treated on site but did not survive the night. His death deeply affected the team and became a painful reminder of the personal cost behind the mission. Years of failed operations left many wondering if the island was beyond saving. By 2005, computer models confirmed what many already feared. Controlling the pests would never work unless every last rat and rabbit was gone. It was a grim conclusion that forced scientists to question the limits of conservation. Should they risk killing everything in order to save what was left? The idea of total eradication felt extreme and dangerous, yet there were no alternatives. When the government finally proposed a plan to wipe out every rat and rabbit on Macquarie Island, the world's reaction was instant and harsh. The plan to erase life itself. By 2007, the Australian and Tasmanian governments announced what they called a final solution, a $24.6 million operation to completely eradicate every rat, rabbit, and mouse on the island. The plan was unlike anything ever attempted in modern conservation. It would use aircraft, poison, detector dogs, and years of monitoring to ensure that not a single invasive animal survived. Officials described it as the last hope for the island's ecosystem, but to much of the public, it sounded like madness. The announcement set off an immediate storm of outrage. Animal rights groups called it ecogenocide. Environmental forums filled with angry debates about whether humans had the right to decide which species lived and which died. International headlines mocked the plan with names like the bait drop of doom. Editorials accused the government of playing God. Even within Australia, protests broke out in major cities. Demonstrators carried signs reading, "Don't kill to save," and "Nature doesn't need bombs." Television commentators said the government had lost its mind. Inside the scientific community, the divide was just as fierce. A group of conservation biologists argued that this was the only way to stop the island's total collapse. They explained that smaller projects had failed because rats and rabbits reproduced too quickly. For every animal removed, dozens more appeared within months. Others were horrified by the scale of the new plan. Some warned that dropping poison bait from helicopters could kill seabirds, insects, and other species that the project was supposed to protect. Soil scientists raised concerns that toxins could damage the island's fragile peat and water systems. Meetings became heated as ethical questions surfaced again and again. Should humans really have the power to erase entire populations, even invasive ones? Despite the moral tension, planning moved forward. Teams of experts spent months mapping the entire island using advanced GPS and geographic information system technology. Every slope, ridge, and wetland was divided into small zones. Each zone would be covered by aerial baiting to ensure no untouched gaps. Over 128,000 rabbits, along with thousands of rats and mice, were targeted. Helicopters were fitted with precision hoppers that released pellets at controlled rates measured by onboard computers. The ground crews would later use detector dogs trained to recognize the scent of rats and rabbits. Chew blocks made of wax and flavored bait would help confirm if any survivors remained. As the plan became public, the backlash intensified. Social media users accused scientists of becoming executioners. Some politicians called for the project to be cancelled after early test drops accidentally killed a number of scavenger birds. Public trust began to collapse. Newspapers questioned whether the scientists were motivated by funding rather than compassion. Officials tried to reassure the public that safety controls were in place, but skepticism only grew. Still, the data was clear. Doing nothing meant the island would soon be beyond recovery. Despite the outrage and the headlines calling it cruel and reckless, the team prepared to act. When the first helicopter blades began to turn, the world held its breath. The operation that would silence an entire island had finally begun. The day nature went silent. The operation began in the early winter months of 2010 under freezing skies and near constant wind. Helicopters rose from the base camp, their blades cutting through fog and sleet, as teams on the ground prepared for what would become one of the most dangerous and ambitious environmental missions in Australian history. Crews operated in sub-zero temperatures, often facing winds that topped 100 kilometers per hour. Over 300 tons of poisoned bait were dropped across 12,800 hectares, calculated by satellite and mapped with precise GPS coordinates. When wind sensors showed speeds too high for safe flying, the pilots stopped mid-air, waiting for the smallest window of calm before continuing. While helicopters covered the open terrain, field teams had to do what machines could not. They crossed cliffs, bogs, and icy slopes carrying bags of bait on their backs. Every few meters, they stopped to scatter pellets by hand and record their position on handheld GPS units. Over several months, they walked more than 1,500 kilometers, often through conditions that felt impossible to survive. The wind was so strong it ripped tent poles from the ground. Workers had to use ropes and rocks to hold down their shelters. The rain froze as it hit the canvas, turning to ice sheets that trapped them inside. When that happened, they used small burners to melt the ice and keep it from freezing. Inside the tents, the temperature dropped so low that water bottles froze solid overnight. Wet clothing had to be slept in because it would never dry otherwise. Some workers described lying awake listening to the storm outside, wondering if their tents would collapse. Meals were reduced to ration packs and melted snow. Communication with headquarters was limited to short satellite calls once or twice a day, often interrupted by static. The isolation was overwhelming. One ranger later said it was the only time in his life he truly understood what it meant to be cut off from the world. When storms lasted for days, teams had no choice but to wait. They read maintenance manuals to stay focused, repaired their gear, and checked maps over and over, planning their next move. The pilots also faced extreme stress. Many missions were flown in near whiteout conditions where the horizon disappeared completely. Flying low to deliver bait, they fought against strong gusts that could flip the aircraft in seconds. One miscalculation could have cost their lives. On the ground, crews worked in short bursts, taking shelter to warm their hands before handling the bait again. Hypothermia and frostbite were constant threats. Food supplies often ran low because flights bringing replacements were delayed by weather. Medical emergencies were treated on site, with rescue flights impossible for long stretches of time. Despite these hardships, progress continued. As the last pellets were dropped, the teams began the long verification stage. Detector dogs, trained to recognize even the faintest scent of rodents, searched every section of the island. Motion-triggered cameras and small chew blocks made from flavored wax were placed across the land to detect any sign of survivors. For months, the island was monitored around the clock. Each photograph, scent trail, or chew mark was logged and analyzed. Slowly, the data began to show a pattern that no one had dared to hope for. Nothing was moving. The Island of Silence. When the last helicopter left Macquarie Island, the world that remained felt unnatural. For the first time in 150 years, there was no scratching, squeaking, or rustling in the grass. Macquarie Island was officially declared free of rats, rabbits, and mice. The scientists who stayed behind to monitor the aftermath described mixed emotions. There was relief that the impossible had been achieved, but also guilt and disbelief. The sense of accomplishment was shadowed by the memory of the destruction that made it possible. For months, they had lived through an operation that erased every mammal on the island. When it was over, the silence felt wrong, like something had gone missing from the natural order. The land looked lifeless, stripped of motion and sound. Some of the workers said the stillness felt like punishment, as if the island itself was angry. Internal reviews later revealed that several team members developed severe insomnia and panic attacks after returning home. They would wake in the night thinking they still heard the choppers or the sound of rain on empty ground. One scientist stopped sleeping altogether, saying that each time he closed his eyes, he saw the dead landscape stretching endlessly. Another refused to return to fieldwork again. A few were sent to counseling, but the nightmares continued. One field officer described it in his report with a single line that unsettled everyone who read it. "It's like we turned off the sound of the planet, and it hasn't come back." Work continued despite the emotional strain. Monitoring equipment was left in place to confirm that no pests had survived. 92 motion cameras were set to record movement 24 hours a day. Hundreds of bait stations were checked weekly. 10 detector dogs rotated between search zones, covering the island step by step. For weeks, every report that came in said the same thing. Nothing was moving. The island remained still. While the silence persisted, the scientists noticed other, quieter changes. The carcasses left from the eradication began to decompose. Tests showed short-term spikes in soil toxins from the breakdown of the bait and remains. It was expected, and within months, heavy rainfall diluted the contamination to safe levels. The soil's chemistry slowly began to stabilize. Stream samples taken after the rainy season showed that water clarity had improved. By the end of the first year, there were visible signs that the island was beginning to recover. Soil moisture levels increased by 15% because vegetation loss had finally stopped. The slopes that once bled mud into the ocean began holding together again. Small mosses and cushion plants started pushing through the peat, their green color returning to places that had been bare for decades. The streams that had once run dark with silt were now clear enough to see the bottom. Rangers who had once walked through lifeless terrain found signs of growth, and for the first time, they began to believe the island might actually heal. The stillness of the island remained, but it no longer felt dead. It felt like something waiting to begin again. The eerie silence would soon give way to something no one predicted. When nature fought back. The transformation began so quietly that no one noticed at first. Then it accelerated into something that defied every scientific model. Within 2 years of the eradication, vegetation surveys showed a 20 to 30% increase in plant cover across Macquarie Island. Slopes that had been stripped bare for decades were suddenly turning green again. The first signs were small, moss patches clinging to the edges of the peat, but soon the growth became unstoppable. Giant herbs such as Pleurophyllum and Stilbocarpa, once considered nearly extinct on the island, reappeared in clusters so dense that researchers had to cut paths through them. In some areas, plants grew waist-high in a single season. Soil analysis showed stability had improved by nearly 80%. The land that had been breaking apart for generations was finally holding itself together. As vegetation returned, the island's wildlife followed. The first seabirds to arrive were petrels, then prions followed by shearwaters. Within 3 years, nesting activity exploded. The birds reclaimed cliffs that had been silent for a century. The air filled again with the sound of wings and calls echoing across the valleys. By 2020, there were more than 100,000 active breeding burrows, a number no scientist had predicted. Some species had been completely absent from the island since the early 1900s, yet they returned as if drawn by instinct to the place their ancestors once knew. The guano they left behind enriched the soil, feeding another cycle of recovery. The change triggered a chain reaction through the entire ecosystem. Insects and worms, once scarce, multiplied rapidly. Their activity restored the natural process of decomposition, recycling nutrients back into the soil. As plants grew thicker, the ground began to hold more rainfall. Ponds and wetlands started to reform in low-lying areas where they had long since disappeared. Water that once ran muddy and brown was now clear. The smell of fresh vegetation replaced the sour, decaying odor that had hung over the island for years. For scientists who had spent decades documenting decline, it felt like witnessing the island breathe again. Researchers began referring to the process as ecological acceleration. Recovery was happening 10 times faster than any subantarctic model had predicted. Satellite images taken from orbit showed vast patches of green spreading across the island, clear enough to be seen from space. Botanists revised their predictions again and again, but could not keep up with the pace of change. It was as if nature had been waiting for the chance to rebuild. The scientists who had been mocked the most were now the focus of praise. The very commentators who once called the project reckless now described it as visionary. A few critics refused to admit they had been wrong, saying the recovery was luck, not proof of success. But the data was clear, and the island itself was living evidence. The mission that had once been condemned as cruel had restored an entire world. Still, not everything about the revival would remain bright. The revenge of the island. The celebration did not last long. As scientists continued to monitor Macquarie Island, new and unexpected problems began to appear. The very speed that had amazed researchers now produced complications that no one had predicted. Swamps began forming in low-lying areas where vegetation had regrown faster than the soil could stabilize. The heavy roots of new plants trapped water, shifting drainage lines that had remained unchanged for centuries. Some slopes became waterlogged, and small landslides returned not from erosion this time, but from the weight of the recovering land itself. The island's victory over decay had created a different kind of instability. As the giant herbs and grasses spread, certain species grew too well. Megaherbs that had once been near extinction began to dominate entire sections of the island, covering slower-growing plants and limiting biodiversity. Botanists found that in some areas these aggressive species had replaced almost all other vegetation, creating thick monocultures that blocked sunlight from the ground. What had been a fragile ecosystem on the verge of death was now an ecosystem struggling under the force of its own revival. The animals, too, began to change in ways that no one had expected. Scavenger birds that had fed on carcasses during the eradication years now had populations far larger than before. Their numbers created new competition for food and nesting space with native seabirds. Some species that had made spectacular comebacks found themselves displaced once again, not by predators, but by the unbalanced abundance of others. Researchers also discovered that a few invertebrate species, which had adapted to life on the barren, eroded ground, vanished completely once vegetation returned. These small creatures had survived when nothing else could, but they could not live in the new, thriving environment. Ecologists studying these shifts came to a sobering conclusion. Restoration had not recreated the old island. It had produced something entirely new. The balance that existed before human interference was gone, replaced by a different self-organizing system. Instruments recorded changes in local humidity, fog patterns, and soil temperature that affected the island's microclimate. Some researchers described it as the island rewriting its own rules. The landscape was alive, but it was no longer the same one that had been lost. Even with these challenges, the success of the operation could not be denied. Since 2011, vegetation coverage has increased by more than 500%. The rabbit population has dropped from around 125,000 to 0. Over 40 seabird species are now breeding again. The story of Macquarie Island became a case study in universities and conservation programs around the world. Teams in New Zealand, South Georgia, and South America used drones, GPS mapping, and artificial intelligence to replicate its methods. Governments introduced stricter biosecurity laws to prevent invasive species from returning. But for the people who had been there, the triumph was not simple. They knew the cost had been enormous. To restore life, they had destroyed it on an unimaginable scale. The project changed the meaning of conservation forever, showing that saving nature sometimes meant committing acts that felt anything but natural. The world called it a miracle, but those who carried it out could never celebrate without hesitation. For them, the island's silence still echoed in memory, a reminder that the line between salvation and destruction on Macquarie Island had vanished forever. What do you think about the decision to wipe out every rabbit and rat? Comment down below. Thanks for watching. See you in the next one.